Advanced Algebra 3.4, we're going to look at the discriminant. So the discriminant is the part that's underneath the square root in our quadratic formula. So our discriminant is this b squared minus 4ac. So if we think about where it is in the quadratic formula, that number in that radical is going to tell us a lot about what kind of answers we're going to have here. So we really kind of have three options here. One of them will break up into two more options even in a minute. So our number in that radical could be positive, it could be 0, or it could be negative. So let's start with a positive. If I have a positive number under that radical, now sometimes I'll be able to take the square root of that evenly, and sometimes I won't, but I always will get two real solutions. If I can take the square root, they'll be rational values, rational numbers. If I can't take the square root evenly, they'll be irrational answers. And that's just two branches of a real solution. If it is 0 in there, then I don't have the plus or minus part. I'm left with just negative b over 2a. So I'll get one answer. This number will be a rational answer. Okay, so I don't have any radicals left in it, no square roots left. And then the last case is when I have a negative in the square root. When I have a negative in the square root, that is not going to be a real number. So I'll have no real solutions. It actually is going to result into imaginary solutions, which will come soon. So these are my three different cases. Now remember, these solutions also connect with our x-intercepts. Okay. So however many real number solutions we have will be how many x-intercepts we would have for this function. So if it was a positive discriminant, there would be two x-intercepts. If our discriminant was 0, we'd have 1 and just touch the x-axis. And if our discriminant is negative, then that parabola doesn't touch the x-axis at all. So it's completely above it or completely below it. So the x-intercepts correspond with the number of real solutions. So we're going to look at this problem here. We're going to find out what our discriminant is here. So it's going to tell us about our number of solutions we have within our x-intercepts. So again, I have to set it equal to 0, just like I would have to in the quadratic formula. So I want my x squared term to be positive. So I'm going to subtract the 3 from both sides and add the 3x. So I'm moving everything to the left-hand side. So I'll end up with a 4x squared plus 6x plus 9 equals 0. So a is 4, b is 6, and c is 9. All positive numbers. So I'll do 6 squared minus 4 times 9. And when I multiply that together, I get negative 108. So what that means is I have 0 real solutions. I also have 0 x-intercepts. If I was to graph this equation when it's set equal to 0, it would cross the x-axis all. So if I see that a value being positive, it opens up, just be above it, doesn't cross it at all. So the discriminant, it helps us actually to tell us what kind of solutions we'll have, what kind of x-intercepts we would have, and then also the other thing is if we can factor it. And if it was a number in that radical that we could take the square root of, so it's including 0 or any perfect square number like 1, 4, 9, 16, 25, we could factor it. So it has to be a positive value for that to happen too. But a discriminant is really telling in those manners.